perspective. So this leads us to the barn ladder paradox. I want to frame this in a specific problem. The idea of the barn and ladder paradox is that I have a barn and I have a ladder. The ladder is too big to fit in the barn. This is a one-dimensional barn and a one-dimensional ladder. And my ladder goes like this. And I'm too dumb to move it. I'm not a very smart guy. But I read about some of this special relativity. I'm a really ambitious, not very smart guy. And I'm really strong and fast, so I thought, what if I take this ladder, and I just race it at some incredibly fast speed. I read about, if I do that, my ladder is going to shrink. And so I'm going to be able to fit my ladder inside the barn. And that's going to be wonderful, because that's where I want it to be. Of course, I also have some degree of foresight. I'm a really weird guy. I have the foresight to know that if I do this, I'm just going to smash into the side of my barn, and that's not going to be good for the barn. But what I really want to do is to fit it in at one point in time. I just want to, it's a matter of pride. I want to get the ladder in the barn, even if just for one moment. So I do that. I have an open door initially. I run the ladder in. The moment the ladder gets inside the barn, I snap close the front door, and I say, ha-ha, I did it. But then I immediately open up the back door so I don't destroy all my property. Flies out like so. So that's the idea of the barn ladder paradox. Actually, it sounds kind of self-consistent when I say it like that. Can anyone think of a reason why this would be paradoxical?
But isn't the barn supposed to be shrinking too? You're moving relative to the barn.
Wait, why would the barn shrink?
I mean, you look skinnier whether you were running or I was running.
Let's see here. Well, who thinks the barn's going to be skinnier? It's all a matter of perspective. Yeah.
Yes. Based on your logic of both things shrinking relative to each other, then the ladder, or I would see the barn shrinking as I was trying to cram the ladder in, and the barn shrinking, and it's impossible to fit the.
So the barn is the ladder shrink?
The barn? Yeah.
Well, okay. So this is okay. So the barn thinks that the ladder is shrinking, and so it fits, and the barn's happy with this, because that's what you want to do ultimately. But if you're the ladder, then you're saying is that the ladder is at its regular full length here, and it's already too big to fit in the barn if it's standing still. But now, I've gone and made the barn move with some relative velocity, and now the barn's like this big. Well, geez, way to go, guy. It's totally defeated your purpose here. There's no way it's going to fit in the barn at the same time. You can't even do the diagonal thing, and you forget about it. Yeah.
Once you're inside the barn, don't they have the same frame of reference, so they're just going to be their normal size to each other? Like that instant that it's in the barn and you close the door.
That's only position.
It's not moving in relation to the barn.
It's not. Ooh, so this is an interesting idea. So we can always take a snapshot. If we have any kind of relative motion, I can always say, stop, and maybe you're always moving, but I can imagine a snapshot in space and time here. Does the ability to articulate the idea that we all stop together, does that mean that I stop moving in slow-mo, or that I stop being skinnier?
I don't know.
Well, in fact, the effect here, it all goes back to our gamma factor, and gamma only depends on velocity. That's the only thing gamma cares about. So all these crazy effects only care about velocity, to source them, to make them all crazy. And so as long as I'm inside this barn, as long as I have this velocity, I mean, I can look at a videotape of this and stop at a freezed frame, but that doesn't mean I stop moving for that freezed frame. As long as I still have that velocity, these effects are still going to be totally in motion. Okay, so I'm going to start a little tally here. How many people think that the barn is correct? We've succeeded. We've gotten the ladder inside the barn. Who thinks this is the outcome of what happened? All right. He's a physicist. You might want to listen to him. He's pretty smart.
Okay. One vote for the barn.
How about the ladder? Who thinks, sorry, the ladder couldn't fit when you were at rest. Now all you've done is shrunk the barn more. Guess what? It's not going to fit. Who thinks that the ladder is not going to be able to fit inside the barn at one point in time? 1, 2, 3, 4, 5, 6. Okay. Really confident like that. Okay, so we got like 12 or so.
So what do you mean? Are you talking about the shrinking, or are you talking about the saying it's the same relationship still?
So I'm specific. Yeah, that's a very good question, because the whole premise here is that ultimately we are talking about relativity. That it's are you shorter or am I shorter? It depends on who you're asking, really. But in this case, I'm trying to frame a very explicit question, and the question is there a point in time, just for a snippet of a second, where the ladder was inside of the barn entirely, just for 1 minute? Or did it never happen? Did the ladder never manage to totally fit inside the barn at the same point in time? So thank you, by the way, because I should have, that's a better way of phrasing it. So framed like that, now is anybody on the barn side? Does anyone think that for just one snippet of time, the ladder fit inside the barn? And that's all it's asking.
Is the barn moving? Or sliding?
The barn's sitting in the plantation.
Yeah, and the ladder's.
And I'm running.
Yeah, okay.
Thank you. This is my speed of light run.
And you're running with the ladder?
Yeah. Oh yeah. That's a big one.
What
Yes.
if we want to vote more than once?
You can come up with more options. Do you think it's something else?
Well, it's a paradox, so we've got to be both.
It's gotta be. That's what a paradox means.
Yeah, I agree with Elkie. I feel like the barn would see the ladder as smaller, and you would see the barn as smaller.
Okay. What if I made a consequence to this? What if I said that if these could both close at the same time, and this triggers a bomb which blows up everybody, but if it doesn't close at the same time, the bomb's fine. No one dies. And the question is, does everyone die? And that's not a matter of perspective.
No. But if
Oh, you don't have to answer that. I'll put you on the spot.
But if I agree with Elkie that they're both happening simultaneously, it sort of averages out to right back where you started, which is that the ladder still doesn't fit in the barn, but it's not way too big or way too small.
So that's actually a really interesting way of looking at things, and ends up being a totally bizarre way of trying to examine the physical situation, but completely accurate for quantum mechanics. And I'm not going to get into why, but I think it's very cool that the idea of there are these different ways in which this could happen, and let's just average out the results to find out what actually happened. I'm going to say that in this case, it's a zero-sum game. In this case, I am looking at an objective quality. It blows up or it doesn't blow up, and we don't average out the results to it. But that's a really cool way of looking at it. Joel?
I have a question. Does gamma affect time and distance physically affect them, or does gamma affect the perception of time and distance?
What do you mean? What's the difference between perception and reality?
Oh,
That was well, if you set the bomb there, reality would have a bomb go off or not. But if we're talking about perceptions, that's the
Well, they're going to agree if they blow up or not. There's not going to be any disagreement on that matter. They're going to be totally on the same page of whether or not they were annihilated by this experiment. But here's one way of phrasing what I think you may have been getting at about that. Let me know if I'm correct or not. I think it's a very plausible way of trying to reconcile some of these ideas to say that, like, for instance, the Lorentz contraction aspect. If you're moving next to me and I see you being very skinny, maybe I am a great scientist and I've got the best measurement apparatuses I possibly could have, but it just takes a little bit of time for light to reach me from both of your sides, and maybe there's something about that, which, the front, it's like the back is going to reach me before your front reaches me, and so there's something like that, and I conclude that you're shorter, but in reality you're not. Sorry, no. That's a great perception, and it's very valid. It's entirely plausible. But it turns out what special relativity says as a theory is that